Picture this, folks, we're talking about a daring mission, billions of kilometers from home. The target, a tiny, spinning, diamond-shaped rock named Ryugu. And the intrepid explorer? A plucky Japanese spacecraft, Hayabusa2. This wasn't just a flyby, oh no. Hayabusa2 didn't just visit Ryugu. It landed, shot at it, bombed it, and then made off with the goods. This mission, orchestrated by the Japan Aerospace Exploration Agency, or JAXA, was a sequel. A follow-up to the original Hayabusa mission, which had its share of drama. But Hayabusa2? It learned from its predecessor. The goal was audacious, to bring back pristine samples from a C-type asteroid. These are carbon-rich asteroids, the kind that might hold clues to the very origins of life on Earth. Why go to all this trouble? Because asteroids are like time capsules. They've been drifting around our solar system for billions of years, largely unchanged. They witnessed the birth of planets. They might even have delivered the building blocks of life, water, and organic molecules to a young Earth. So, by studying them, we're essentially looking back in time. It's cosmic archaeology, people. And Hayabusa2, our little space ninja, was perfectly equipped for this grand heist. It wasn't just about getting there. It was about interacting with an alien world, a world with incredibly low gravity, a world covered in boulders. So, what's the big deal with asteroids anyway? Aren't they just rocks? Well, yes and no. They are rocks, but they are rocks. Think of them as the leftover construction material from when our solar system was just a baby. While planets like Earth were forming, clumping together material, these smaller bodies never quite made it to full planethood. They are the cosmic crumbs left on the table after the planetary feast. These space relics come in different flavors. We've got S-types, which are stony. We've got M-types, which are metallic. And then there are the C-types, like our friend Ryugu. The C stands for carbonaceous, meaning they are rich in carbon. And where there's carbon, there's often organic molecules. The very stuff life, as we know it, is made of. Let's give a round of applause for the star of our show, the Hayabusa2 spacecraft. This isn't your average satellite. It's a marvel of engineering, a compact bundle of scientific ambition. Weighing in at around 600 kilograms, about the size of a small car, if that car was bristling with antennas, solar panels, and some seriously cool gadgets. It was designed by the brilliant minds at JAXA, the Japan Aerospace Exploration Agency. These folks are the space samurai of the modern age, pushing the boundaries of what's possible with ingenuity and a whole lot of dedication. Hayabusa2 was packed with instruments. It had cameras to see Ryugu in stunning detail, spectrometers to analyze its chemical makeup from afar, and a laser altimeter to map its lumpy surface. But the real showstoppers were its sample collection mechanisms. We're talking a sampler horn designed to gently kiss the asteroid's surface and puff up some dust. And for the more stubborn bits, well, that's where things get explosive, but more on that later. December 3rd, 2014. That was the day our cosmic adventurer, Hayabusa2, began its epic journey. It blasted off from the Tanegashima Space Center in Japan, riding atop a powerful HTA rocket. Imagine the scene. The roar of the engines, the ground shaking, and this little emissary of humankind soaring into the sky, leaving Earth behind. Its destination? Asteroid 162-173 Ryugu, a tiny speck of a world orbiting the sun, hundreds of millions of kilometers away. This wasn't a quick trip around the block, this was a marathon, a multi-year chase across the solar system. The journey itself was a feat of celestial navigation. Hayabusa2 didn't just point and shoot, it used Earth's gravity for a slingshot maneuver, a gravity assist, in December 2015. This clever trick gave it an extra boost of speed and adjusted its trajectory, flinging it out towards Ryugu's orbit. Think of it like a cosmic figure skater using a partner to gain momentum for a spectacular spin. All the while its super-efficient ion engines were humming along, gently but persistently pushing the spacecraft, sipping tiny amounts of xenon gas to create thrust. These engines are the marathon runners of space propulsion. Section 5. Arrival at the Dragon's Palace meeting Ryugu, June 27, 2018. Mark that date, folks. That's when Hayabusa2 finally arrived at its destination, the asteroid Ryugu. Ryugu means Dragon's Palace in Japanese, a name taken from a folktale about a fisherman who visits an undersea palace and returns with a mysterious box. How fitting, right? Our spacecraft was about to visit this cosmic dragon's lair and attempt to bring back its own treasure box, filled with primordial secrets. After a journey of over 3 billion kilometers, Hayabusa2 settled into a home position about 20 kilometers above the asteroid. The view must have been breathtaking. And what a strange and wonderful world Ryugu turned out to be. As Hayabusa2 got closer, the images it sent back were astounding. Ryugu wasn't the smooth, dusty body some had expected. Instead, it was a jumble of rocks and boulders, almost like a cosmic rubble pile barely holding itself together. Section 6 Operation Touchdown, the Space Gun Gambit. Now for the really exciting part, the sample collection. JAXA had identified a few potential landing spots, but Ryugu's boulder-strewn surface made it incredibly tricky. It was like trying to find a parking spot in a cosmic rock garden. After much careful analysis, they selected a small, relatively clear area named Tamatabako, another nod to the Japanese folktale, meaning treasure box. The first touchdown attempt was scheduled for February 2019. The tension in the JAXA control room must have been palpable. This was the moment of truth. The plan was elegant yet audacious. Hayabusa2 would slowly descend towards Ryugu. As its sampler horn, a meter-long tube extending from its underside, made contact with the surface, the spacecraft would fire a small, 5-gram projectile, a tantalum bullet, into the asteroid. Think of it as a tiny space gun. Section 7. Making a dent the SCI bomb and digging deeper. Hayabusa2 wasn't done with Ryugu yet. Surface samples are great, but scientists really wanted to get their hands on material from the surface. Why? Because the surface of an asteroid is constantly bombarded by solar wind and cosmic rays. This space weathering can alter its composition over millions of years. Subsurface material, on the other hand, is more pristine, better preserved, offering a clearer window into the asteroid's original state and the early solar system. So how do you get to that subsurface stuff? You make a crater, enter the Small Carry-On Impactor, or SCI. This was, essentially, a space bomb, a copper projectile about the size of a baseball backed by a shaped charge of plastic explosive. The plan was for Hayabusa2 to release the SCI, then quickly maneuver to hide behind the asteroid to protect itself from the shrapnel. The SCI would then detonate, slamming the copper impactor into Ryugu at high speed, creating an artificial crater. It sounds like something out of a Michael Bay movie, but this was all in the name of science, I promise. It was a bold, high-stakes operation. Section 8. The Precious Loot. What Ryugu's dust bunnies revealed. With its precious cargo secured, Hayabusa2 bid farewell to Ryugu in November 2019. It fired up its ion engines once more, this time for the long journey back to Earth. Imagine the spacecraft, a tiny cosmic courier, carrying a message from the dawn of the solar system. The samples it held, though minuscule in quantity, just over 5 grams in total, were immeasurably valuable. These weren't just specks of dust and rock. They were keys to understanding where we came from, and perhaps whether life exists elsewhere in the universe. On December 5, 2020, the moment of truth arrived. As Hayabusa2 flew past Earth, it released its sample return capsule. This capsule, protected by a heat shield, blazed through Earth's atmosphere like a shooting star, before deploying its parachute and landing gently in the Woomera prohibited area in South Australia. The recovery team, guided by a beacon, quickly located the capsule. Mission accomplished. The treasure box from the Dragon's Palace was home. Section 9. Homeward Bound and Beyond. Hayabusa2's Encore. After successfully delivering its precious cargo, you might think Hayabusa2 would get a well-deserved retirement. A quiet drift into the sunset, perhaps? Not a chance. This little spacecraft is a workhorse. With plenty of fuel still left in its ion engines and its instruments still functioning perfectly, JAXA decided to send Hayabusa2 on an extended mission. Why let such a capable explorer go to waste? There are more cosmic mysteries to solve, more asteroids to visit. So, our hero is back out there, venturing even deeper into space. Its new targets are 2 more asteroids. First, a high-speed flyby of a small asteroid designated 2001 CC21, expected around July 2026. This will be a quick hello, a chance to test its instruments at high velocity and gather some bonus science. But the main event of this extended mission is a rendezvous with another asteroid, a tiny, rapidly rotating body named 1998 KY26. Hayabusa2 is expected to arrive there in July 2031. This asteroid is much smaller than Ryugu, only about 30 meters in diameter, and it spins incredibly fast, completing a rotation in just over 10 minutes. Studying 1998 KY-26 will present new challenges and offer new insights. How do such small, fast-spinning asteroids hold themselves together? What are they made of?